Good morning, ladies and gentlemen. My name is Stefan Ringbeck from Intersolar, and I'm Product Marketing Manager. Today in our webinar we talk about the new cost-efficient solution, what we presented at the Intersolar Europe 2017. The webinar will take approximately 25 to 30 minutes and additionally questions. If you have questions, please write them in the question pane or in the chat, and at the end of the webinar I will go to the chat and to the question pane and looking for the question and answer directly the questions. After the webinar, the presentation and the recording, those webinar will be recorded, will be shared and distributed in the follow-up email. Today, since our main target and our objective is to reduce the LCOE, the levelized cost of electricity for our customers, first we have to look up the definition of the LCOE. The LCOE are the total costs divided by the produced energy. The total costs are covering for sure the capex, the investment, the system cost, the financing cost, and the operation maintenance cost. We also can see here a short sum up to define how we can get low LCOE. So it's important to have a high energy production rate, because the energy, the produced energy, the higher it is, as the higher the energy, the produced energy is, the lower the LCOE is. Then high reliability. The high reliability are impacting directly the costs, because you have lower operation maintenance costs. Since with products who survive the complete project lifetime, you don't need to exchange, you don't need to repair, you don't have as much as downtime, and downtime means lower energy production, and replacement means high maintenance costs and low cost of installation. If you sum up these points, you add up at a low LCOE and a high value for our customers, and that's our main objective. During this webinar, I will always relate it back to this graph. This graph is made from Green Tech Media and showing the variable components of the LCOE for first solar power plant in the United States. There we have several sections. We have the BOS fixed, the BOS variable. The BOS fixed, as BOS, are balance of system, for example, inverter, cabling, substructure. The fixed BOS are typical for utility scale projects, are typically inverters. If you're on a rooftop with limited space, then for example fixed BOS cost would be the substructure. Variable BOS costs are typically for utility scale substructure, cabling, combiner boxes. For a rooftop installation would be, for example, the inverter, because the inverter can, depending on how efficient the modules are, you may need a stronger one. Then we have the module costs. Then we have the financing costs and the OPEX, the operation maintenance, and the development cost for project development. Why is efficiency so important? Efficiency is important, for example, as you can imagine, if you have a high efficient module and you have a defined number of modules, some specific costs will reduce. For example, for storage, transportation, and packaging. If you have more efficient modules packed on one pallet, the cost per pallet go down, because the pallet are absolute costs, and then you have the module cost, and they are depending on the efficiency. The same for the transportation cost, because you transport with one container more capacity. Then as well the land lease or the land cost, because you can reduce land, for example, for the same power plant size. Then directly, what you can see directly always is the BOS costs, the balance of system, for example, cabling, substructure, installation. Because if you want to install, for example, 10 megawatt power plant or 50 megawatt power plant, you need less cables, because you have a lower number of modules. And maintenance, because you also have a lower number of modules. Here in the graph below, you see the different section what gets impacted by possible reductions. that are the BS part, the flexible, the fixed one, and the variable one. Then the operation maintenance part and the financing, because you have reduced investment costs. But with increased efficiency, it's possible to have increased module costs. On the right hand side, you have here a diagram. The diagram are showing the levelized electricity costs, so the target LCoE, and the module cost in dollars per square meters. And then you have a planning target. And for example, if you take out, let's say we have module cost of approximately $100 per square meter, then you see with 20% efficient, you end up at roughly 6.5 to 7 cents of LCoE, and if you're going in direction of 25, it's approximately 5. So you need something between 20 and 25, though here it would be approximately 23% to meet your target with the plan, or you meet your planning target. If you're looking down on lower costs, you can see that, for example, at $50 per square meters, if you want to reach the 6 cent per kilowatt hour, a module of approximately 15% efficiency is required. Now we came up to the news. One of the first news what we are displayed and shown on the Intersolar was the DUOMAX with Gecko grip. What are Gecko grip? Gecko grip are small metal rails bonded on the backside of the module. The advantages of the bonded rails on the backside is a better load distribution. Because as you can imagine, we have here, if you compare it with clamps, then you have the clamps installed on the edge of the module. Then you have here, and compared to the Gecko grips are moving to the inside of the module. That means the span-width between the clamping points or the supporting points is with the Gecko grip much lower than with the clamps. This leads to a better stress distribution and a lower deflection of the module. A further advantage is that you can install the module more easy because you don't have a clamp what consists of more than one part. Typically, laminate clamp has minimum, beside the screw, minimum 3 parts. That's the rubber part for protecting the glass, and then the bottom metal part and the top metal part. Here is the Gecko grip. You only need to insert the screws, and then you can put it on the substructure, and you don't need it to hold it since it cannot slide down, and then you can screw it from the backside. If we already tested and have experience made in Asia, our experience is that the Gecko grip solution in terms of installation speed is approximately the same like for conventional framed modules, since it's easier to put it in place and screw it from the backside instead of having a clamp to assemble which consists more than one part. The possible reductions are here in the variable BS part and in the operation part. And increase, because it's an additional part, the models will be slightly more expensive. But overall, from the system cost, it's a better solution because even you have lower risk of module cracks during the lifetime because the load distribution is much better compared to clamps. As next, we have shown a 1500 volt framed module, the Tallmax. We already had some webinars about it. What are the advantages? Here is the summary of it. So the advantages to reduce the BOS costs and the operation maintenance costs. For the BOS part, mainly it's a saving in terms of cabling, combiner boxes, and for example inverters, because with 1500 volt you have a higher output voltage. The higher output voltage leads to a lower number of inverters required per system. You have a slight increase of the costs, and you have a reduction in the operation maintenance costs. Why you have a reduction in the operation maintenance costs? As you can calculate based on the longer strings with the 1500 volt, you only need approximately 2/3 of the combiner boxes what you will need compared to a 1000 volt system. This leads that you have a lower number of combiner boxes to check, lower number of connections to check, and that's a clear saving. We had a webinar together with PV Magazine about the 1500 volts. It was in German. There we also discussed the point, is it possible to use 1500 volt systems on rooftops? There we had a specialist from a cable manufacturer who knows very well the standards. The result was that there's no barrier why not using 1500 volt system on roofs, because the most important standard to follow are the low voltage directive, and the low voltage directive is going up to 1500 volts. That means you can use it, and there are also some string inverters available, so you can also start to build up system in a range of, let's say, 30 to 60 kilowatt as minimum size. And then you have the advantages of having higher voltages, reduced system costs, and better, that means lower LCoE. The next one, we had a so-called multi-busbar module. Multi-busbar in our case means that we increase the number of bus bars from 5 to 12. For the 12 busbar module, that is a wire, and you can see it here in the picture that you have a lot of wires as bus bars. The advantage of the wires is that they have a lower, that they totally cover a lower area of the cell. That means more cell area is available. That means more active area leads to a higher efficiency and a higher output. And further advantage of a wire are the better reflection properties. That means the sunbeam, what is let's say hitting the wire, can be easier reflected back to the glass and then back into the cell. That means for the highest benefit, beside the efficiency, especially for locations with high direct irradiation, in general we expect, or according to our development, we expect a power increase from 5 to 10 watt depending on the module. You can see it here with the power range. With the standard one with 5 bus bars, we're going up to 305, and with the multi-bus bar with the 12, it's up to 315, though 10 watts more. The good point is they are directly reducing, or their potential reduces in their variable BS costs part, because here, for example, if you have fixed power, that you need a lower number of modules, or if you have if you are installing them on a roof, you have a higher capacity on the roof, which is reducing relative your substructure costs. But for sure, on the other side, the module might be a little bit more expensive. Then we have the Splitmax. The Splitmax is a half-cut cell module. It reduces the interconnection losses. What does it mean? Interconnection losses means the current gets built up over the cell. And as you can, if you compare it with the cable, so you have a cable, and if you divided the length by half, that means with the cable what has only 50% of the length of our other cable, the losses are reduced. And the same happens here. That means one advantage is the reduced interconnection losses. That increases the power of approximately 5 watt. Another advantage is we have here two 60 cell modules connected parallel to have the same output voltage like a standard module. That means we have two modules, basically two strings, one here on the upper side of the module where 60 cells are connected, and one on the lower side where also 60 cells are connected. Then we have the bypass diode in the middle. Another advantage is with this design is the lower shading losses. In case you have a utility scale project, there will be inter-row shading, though, and if you have the modules installed in a portrait orientation, the shading is coming from the bottom and will shade the lower part. That means we have an impact on the lower section, but the upper section will operate still at the maximum. That means the shading losses are reduced because impact is only on half of the module. Then, based on the increased efficiency and increased power output, we have reductions on the fixed BS part, the variable BS part, and may depending a slightly increase of the module cost. Next, I want to show the bifacial glass module. We also had there, if you for example look on YouTube, we also had their webinar before Intersolar to give you a kind of introduction of the bifacial one. Here we have a short summary. The bifacial module is a module what is active, has an active front cell for sure as all modules, and has an active back cell as well. It's a glass module with a transparent foil. So the module is active from front and back side. The front side power here for 60 cell is up to 300 watt. The impact for the cost is on the variable based cost and on the fixed one, and then there's a possible increase of the module cost. From the system design here, you need to take care that there is no shading on the back side. That means you can clamp the modules on the long side. The supporting rail needs to go along the longer side to have no shading underneath the module. The junction box are designed to not make shading on the active cells, and then you can route the cable along the short side of the module to the next one. How does bifaciality work? So here we have the active, or here we have the bifacial cell. It's active from the front side, active from the back side, and it's packed into a glass module. That means it has all the advantages of a glass module. So what do you need to know? The energy what is gained, or the power what is gained of the backside, is depending on the ground albedo. That means the reflective properties of the ground. That makes difference if you're installing it on snow, on grass, or on a foiled roof, or on black asphalt. In general, you have the irradiation coming from the sun. On the front side, it will be directly absorbed. For the back side, you're using the albedo, the reflectivity of the underground, and then it gets back reflected to the module. That needs a certain distance, because if you're moving down the module, let's say here to closer to the ground, then you can see that the sunbeam, what is reflected back from the ground, cannot cover the whole surface. It has a shorter surface to cover the backside. So it needs a certain distance that the sunbeam are able to reach the center of the module. The albedo, here we have a graph, is quite varying from the underground. So here the highest one, the best you can have, is fresh snow. Then, for example, sand is already a little bit bad. Water can be also quite, even not a good one. The forest grass is even not the best. Desert is a little bit more, though sand is a little bit better, but here you can see directly that the most benefit you would go on a snow. And for the desert, it also depends if you have, for example, the more yellowish desert sand like in Sahara, or the more reddish one like in Australia, or more black one, or ashes from a volcano, for example, like Hawaii, or if you have a salt desert. So what is important to know for the system design and to calculate the benefit of a bifacial module, you also need to know the underground properties of the location. That means knowledge about the location, as it needs more knowledge about the location to make a proper system design, to even avoid that, for example, if you have a quite good reflectivity and you don't consider it in the inverter sizing, that you cut off the additional power because the inverter is running into limitation. And this needs to be avoided to get most benefit out of the bifacial modules. Here are some examples about the albedo and the expected additional energy. First of all, I wanted to start on the upper side with the rear side output calculation. So the rear side output, the back side out power, is depending on 2 points. So one point is the bifaciality properties of the cell. There we have to differentiate between the P-type cell and the N-type cell. The P-type cell has a bifaciality of 60 to 70% approximately, and for the N-type, which is more expensive, it's going above 90%. That means the maximum rear side power is calculated as shown here. We have the front side power multiplied by 70%, the module bifaciality, multiplied by the albedo. That means if you're flashing the backside of a P-type module and we have the 70% and we have a front side power of 300 watt, you can expect a rear side maximum power of 210 watt peak on a 60 cell module. Now if you're comparing different undergrounds, here you see the albedo for grass is approximately 10, for concrete 20, for white roofs, here in this case painted, or better go with a foiled one because it's usually already quite bright, 30, and snow is the highest one with more than 40. The expected energy for grass, what is, let's say, more typical for Europe, is a little bit more than 5%. Concrete can be, depending on the final color, even going in the direction of 10%, a little bit more. For roofs, the ideal roof would be, for example, foil roofs. There you have to take care and make exact calculation because you need a higher distance to the underground. Then you need to calculate if the chosen substructure is sufficient for the installation and if the roof can take the additional load for securing the system on the roof. We are also investing into test systems around the globe on different grounds to see how the modules are performing, as it's not only us, also other companies and institutions who are analyzing bifacial modules around the globe to build up a database to see how the ground albedo and the bifacial gain are related together, because they are also needed for the system design. Though they are, if you have test data, it's much more easier to design and give a guideline for the system design, as additional energy is depending on the ground underneath the modules and the reflective properties. The field performance, here we have a graph. The gray one is a standard module. Then we have here the red one, it's a bifacial with shading, so the rails are underneath the modules and they are making a shadow on the backside. And the blue one is a non-shaded bifacial. That means no shading on the backside. And especially if you look here directly in the beginning, you see that there's a quite big difference between the red and the blue one. So it's very important that if you're using bifacials, that you take a look for the substructure and that the substructure is causing no shading on the backside. Because here we had approximately 8% more gain without shading on the backside compared to a shaded system. We also have a test facility. The test facility is based in Zhengzhou, close to our head office, where also our key state lab, our test center, is placed. There we tested the bifacial modules on a grass underground, and here you can see that we achieved approximately 7% better energy yield with a bifacial module P-type compared to a standard module. Also important is the product quality. We have a product quality, the quality system applied over the whole value chain, starting from raw material to the final assembled product. We also have the key state lab where we're doing all the IEC tests or UL tests. That means all the products we are developing, we know before we're sending it to the test to the IEC test centers, for example the TUV, what will be the result. It's always important for low LCoE to invest into good quality products to have no surprise during the project lifetime. Because, for example, if an inverter dies before it expected to die, or a combiner box died before it expected to die, you have higher operation maintenance costs, and that means higher number of replacements. The same as if the system is not well designed, that means the substructure and the module you have chosen are not working properly together, and you have high risk of module cracks. And with the cracked module you have to replace them. You also might have higher downtimes, and so it's always important to take, especially if you're looking for the lowest LCOE, that you're taking care of the system design, and that you're selecting high quality products to ensure that the LCOE can be achieved. It's important because we can assume that the annual operation maintenance costs are in the range of 1 to 3% of the 1 to 3% of the investment. That means over a lifetime of 20 years, it will be 20 to 60% of the investment, so quite a big portion. And if you don't take an eye on high quality products, then you might have much higher maintenance costs, and your target LCOE cannot be achieved. That's already all. I say already thank you. I will now check for questions. There's one question about how much glass module we sold over the past years. It's already more than 1 gigawatt, so we have a quite huge experience with glass. And if you're looking for the highest reliability, the lowest impact for the PID, for the potential induced degradation, the recommendation is clearly to take a frameless glass module. Then the next one is, this question, if you want to produce framed glass models, that's the question where please contact our sales. Then the next question is, how can the LCOE be simulated also with competitive products? It's always, let's say, the question between the assumption of what will be the failure rate during the lifetime and then the investment cost. So you can also optimize it between if you want to replace or if you want to invest into products who can survive the 20 years or 25 years depending on your project lifetime. Then other third-party tests with Trina products, yes, we are testing, for example, the products or some products with PVL in the US. And the reports also are available. And if you want to know more, please contact our sales department. About the availability for the half-cut cell module and the multi-busbar, there's the best to contact our sales department and to get the information about when they will be available. There's a question about we have there are projects with having problems with soiling, and other products are able to solve this. This depends on where you are. If you're in a desert and the dust and the dirt is sticky on the complete module surface, you have simply to clean. With the frameless, you can reduce, for example, the soiling build-up from the bottom because the frame is working as a barrier. And then if the module gets cleaned or if it's raining, most of the dust gets removed, but with the remaining water, what is collected on the rail, you will always have a little bit of dust and dirt what is collecting and accumulating then more. That means with the frameless modules, you have a better cleaning effect and you have a reduced effect of the soiling cleanup over the time, especially in Europe. If you're in a desert where the sand is sticking on the complete module surface, you need to optimize your operation maintenance strategy because you need to simply clean the modules. So it depends a little bit. If you're here, you can improve it by using frameless modules or increasing the module inclination. And if you're in extreme dusty region with high humidity, so that you have really sticky, then you have to optimize your operation maintenance strategy. The question about the cleaning and maintenance cost, if it's doubled or not, that's hard to answer because they're quite highly dependent on the location and your strategy. So if you have the, you might have, or you see in the first moment you have, if you take the example for the desert, if you do their, let's say, cleanings on a monthly base, you have lower maintenance costs. But if you do it, for example, on a as 2 times per month, for sure you have higher maintenance costs, but you also have a higher energy because, for example, in desert regions, it's easy to lose 0.4% of the output per day, and then you accumulate quite fast a high decrease of power. And by cleaning, you make basically a reset and can gain more energy. So it really depends on the location, what is the best strategy. With the Gecko Group, we have installed several plants, mainly in Asia so far. So it will be several megawatt, or maybe even several 100 megawatt installed. There's one question: can bifacial models be used for carports? Let's say basically yes, it can be used as roofing material. The only point what needs to be checked is if the module what is laminated glass are fulfilling all the requirements for the certain country. So for Europe it can be for some countries more complicated to get the approval. For some it should be easy, but for example we are currently working on a project here in Europe for a carport and using glass modules as roofing material. Also for the cost increase compared from the glass compared to the frame module, please contact our sales. They can give you detailed cost increase. The good point is that even if they are more expensive and even if you have to invest a little bit more on the substructure base with better warranty conditions, you end up at a lower LCoE overall because the degradation is lower due to the better product properties, and that means you have a higher energy output over the years. You're collecting more energy over the years, and since energy production is one of the key drivers for LCoE, it's always good to optimize energy production. I guess I would take one another question, and the remaining question will be then answered in the follow-up. There's a question, bifacial on residential home, does it make sense? For residential, it depends on where you're installing it. If you're installing bifacial on a roof parallel, then the benefit will be close to zero because you don't have enough space and not enough inclination to have the surface underneath as reflector. So you need a certain distance to ensure that the complete rear side gets, let's say that the reflected irradiation, that reflected energy can go or can get or energize complete module surface on the back side. Okay, I would say thank you very much. We will distribute the presentation and the recording and the short Q&A with the follow-up emails. Thank you very much. Have a nice day. Goodbye.